Okay guys, I decided to do a second video for each slide because I know that these kind of get lengthy. So if you wanted to like try a slide and then take a break, we could do it that way. So the longer videos or the longer sets of notes, I think that this is the best way to attack this. And bear with me because this is all new to me. So looking at example 3, this one's multiple choice. So we would still be multiplying by the denominator. So multiplying by the square root of 27 for both numerator and denominator. So again, focus one part at a time. And actually looking through these answers, I could cross B off right away because I still see that there's a square root of 9 in the denominator. And I know that that can't be completely simplified. I also know that the square root of 9 is 3. So that tells you right there that that's also not simplified. So when we take 2 times 27, that gives us the square root of 54. So the square root of 54, sorry, I'm working straight down here. Biggest perfect number that goes into 54 is 9, and that goes in there 6 times. So the square root of 9 is 3. So my numerator at the moment is 3 roots of 6. Okay, switch to the denominator. Remember, they're going to cancel each other out because it's going to give you a perfect square number. So you have 27, 27, 27. So if you go to reduce, does 3 over 27 reduce? Yes. And remember, if you're not good at reducing fractions or this is something that you struggle with, you can put it in your calculator, 3 divided by 27, then hit math, enter, enter. And that kicks you back with 1 over 9. So my final answer is the square root of 6 all over 9. So my answer would be C. Okay, looking at the next one. Now this has 2 parts to the radical. You have a radicane and then you have the other part. So we're still multiplying by 2 roots of 8. 2 roots of 8, okay? Ignoring the denominator. So looking up top, you can multiply 8 times 2 because those are on the outside. So that would give us 16 roots of 8 times 2, which is also 16. And we know that the square root of 16 is perfect. So we would cross the whole thing out and bring out a 4. Okay, so when we multiply, we end up with 64 over, and we don't know yet. So let's finish the denominator. Switching gears and looking at the denominator. Multiply what's out front. So we have 4. 8 times 8 gives you 64. The square root of 64 is 8. So everything worked out perfect here, nice and clean. 8 times 4 is 32. And then when you divide 64 by 32, your final answer is just 2. Okay. All right, let's look at some of these with variables and numbers. And again, on this one, I am going to do this one, skip this one. So you're going to try the other one. So we're going to multiply by the denominator. So we take it by the square root of y to the 4th power. Okay. So our numerator right now, and this is going to be easier than you expect. I know that it looks a little bit intimidating. So we have x to the 6th, y to the 4th. So asking yourself how many can come out, and the fact that they both have an even exponent, you know that nothing is going to be left on the inside of this. So we could take out 3 on the top, 3 x's on the top, and 2 y's on the top. And that's our numerator for now. Then we look at the denominator. We know that the square root signs are going to cancel. So I'm going to be left with a y to the 4th on the bottom. Guys, I gave you this same exact problem back in chapter 7. So now remember, I only have one x and it's positive, so it's staying. There's no reason to move it at all. So x cubed stays x cubed. However, I have 2 y's that are separated by division. So the division, the rules of exponents for division say that you subtract those exponents. So 2 minus 4 would give me negative 2. And remember, you put it on the bottom and it becomes a positive 2. So that would be your simplified form there. So try this one up here. Again, answers will be in Google Classroom. If you have questions, make sure that you reach out and ask. So these ones actually look a lot harder than they are. I think these take less time than the other ones, but you can be the judge of that. So this is where we're going to talk about the conjugates. So remember, if I see a minus down here, I'm going to be multiplying by a plus. If I see a plus down here, I'm going to be multiplying by a minus. Okay, so the conjugate of 4 minus the square root of 5, because again, we cannot have the radical in the denominator, so we have to rationalize it. You're going to multiply by the whole thing. So you're multiplying by 4 plus the square root of 5. And that goes for both. Okay, focusing one place at a time. That's kind of been our theme through this entire set of notes. Now, when you're taking 2 times this, you want 2 times the entire quantity. So you have to put that in parentheses. So you are distributing this 2 to both. So 2 times 4 would give me 8 plus, now this is outside, this is inside. They are not getting multiplied together. That is not the square root of 10. It is 2 roots of 5. That's it. There's nothing you can do on the top. You cannot add these together. We haven't gotten anything about any of that. So that just stays 8 plus 2 roots of 5. Look at the bottom. Now, this can get a little bit more challenging, but you're taking all of this times all of this. Now, if you recall back to chapter 8, spiraling, guys. Going back to chapter 8, we would have to FOIL this or distribute. But I know for a fact that those middle terms are going to cancel out because I'm going to have 4 roots of 5 minus 4 roots of 5. So don't even spend the time doing that. Don't confuse yourself. You are still going to have 4 times 4, which is 16. And then I have negative square root of 5 times positive square root of 5. So a negative times a positive is always going to be a negative. Square root of 5 times the square root of 5 would be the square root of 25. What's the square root of 25? 5. Look how nicely that all canceled out. So the next step we have is rewriting the numerator. Nothing changed there. And now I'm asking that you just do the subtraction for the denominator. So you have 16 minus 5, which is 11. Now this can be written as 2 separate fractions. We have it all written as 1. So 8, 2, and 11. Can that reduce? Can I divide the same number out of all of them? The answer is no. So my answer is finished. And you never concern yourself, guys, with what's left underneath the radical because we know that that's completely simplified. Okay, let's try it again. So looking at the next one, I see the radical symbol in the denominator. So multiplying by the conjugate, which is 5 minus the square root of 2. And I'm going to focus on the numerator first. So you can put parentheses around it. Distribute. 3 times 5 gives me 15. Minus sign stays. And this guy becomes 3 roots of 2. Nothing else can be done there. Over. Again, these middle symbols are always going to cancel, guys. So multiply here. 5 times 5 is 25. Positive times a negative is a negative. Square root of 2 times the square root of 2 is the square root of 4. The square root of 4 is 2. They cancel, guys. So do your subtraction. 25 minus 2. Numerator stays intact for now. And 25 minus 2 gives us 23. So 15, 3, and 23. Can anything come out of all 3 of those? The answer is no. So we leave it alone. Okay, so this next slide, you guys are going to do by yourselves. So example 6, you do, check it, okay? And then let's look at just a couple more. I am also going to have you do example 7 by yourself since that one's multiple choice. And I will do both problems on example 8. So I might use some of this extra space here since these get a little bit longer. So looking at this first guy up here, at this point, you guys should be familiar. I'm going to take it and multiply by the conjugate of 4 plus the square root of 5. Okay, put parentheses around it. Distribute that 2. So 2 times 4 is 8 plus 2 times the square root of 5 is 2 roots of 5. All divided by, and I can't do anything else up there. That's finished. Focus on your denominator now. 4 times 4 is 16. Negative times a positive, this is always going to be a minus sign because you're always multiplying by the conjugate, which is the opposite symbols. Square root of 5 times the square root of 5 is the square root of 25. Square root of 25 is just 5. Do your subtraction. So 16 minus 5 gives us 11. And 8, 2, and 11, nothing can reduce out of all three of those, so you leave it alone. Now, I know that you might be thinking, oh, I'm never going to have to reduce those, but that's not true. If you tried example 7, you saw that you do have to reduce sometimes. Okay. Now, this last one is a little bit different. So I'm actually going to write this below here, just putting the same exact problem. So it was 3 over the square root of 7 minus the square root of 2. So that's the problem that we were looking at. Slide that up. So you're still multiplying by the conjugate. So you have multiply it by the square root of 7 plus the square root of 2 for both. Okay, focus on the numerator. Remember, outside, inside, outside, inside. So when you put parentheses around this and you distribute, that's just 3 roots of 7 plus 3 roots of 2. Can I simplify 7? No. Can I simplify the square root of 2? No. So that's it for up here. Don't try to add these together. These are not alike. They're not the same. So all of this is divided by the square root of 7 times the square root of 7. Square root of 49, which is just regular old 7. Minus symbol stays because you have a negative times a positive. Square root of 2 times the square root of 2 is the square root of 4. Square root of 4 is 2. Do your subtraction. So you have 3 roots of 7 plus 3 roots of 2, all divided by 7 minus 2 is 5. 3, 3, 5. Can anything be simplified from those? Answer is no. So we leave it alone. Okay, so hopefully that makes sense. Again, if something didn't, or you tried the example problems and they didn't work, please let me know and we will address it.